Scientists have found a way to extract energy from the air. Researchers from the University of Massachusetts Amherst have demonstrated to the world a device that can continuously obtain electricity from moisture in the air. What's more, almost any material can be turned into similar hardware, as long as it is filled with nanopores with a diameter of less than 100 nanometers. However, this solution is not yet ready for practical use. But, according to its creators, it goes beyond some of the limitations of other methods of obtaining energy. From year to year, humanity's demand for electricity is increasing. Where else can we get it? It turns out that some of its potential sources are difficult to see, but this energy is literally at your fingertips. This was proved by researchers from the University of Massachusetts Amherst. They have developed a device that can draw energy using the humidity of the air. The description and results of the research were published in the journal, Advanced Materials. The condition for the operation of the device developed by American researchers is air. And perhaps not the air itself, but its appropriate humidity. To illustrate this, we only have to think about the cloud for a moment. As we know, it is a huge cluster of water droplets. And each of these droplets has an electrical charge. When conditions become favorable, these charges can cause lightning to form in the cloud. However, so far, obtaining electricity directly from lightning is beyond our capabilities. Therefore, one should try to use this energy before lightning strikes. And that's the idea of a group of scientists. So far, they have managed to create a small cloud in the laboratory that is able to produce energy in a controlled and predictable way. But how is such a thing even possible? What is the mechanism of operation of such a current generator? Well, according to the authors of this method, it is relatively simple. For this, we only need a porous material in which the pores, or rather nanopores, would be only 100 nanometers in diameter. This seems like one of the tasks of the genre easier said than done, although it is not impossible. In any case, referring to the size imaginable for us, it is roughly 1,000th the thickness of a human hair. Why 100 nanometers? This is due to a parameter known as the mean free path, which is the distance a single molecule of a given substance, in this case water in air, travels before colliding with another single molecule of the same substance. When water molecules are suspended in air, their mean free path is about 100 nanometers. How it's working? A thin layer of nanoporous material can be made of, for example, cellulose or graphene oxide. Water molecules in the air easily penetrate into the nanopores. Later, they gradually descend from the top down. However, along the way they move along the walls of the pores. This means that the top of the layer of porous material would be bombarded with much more charge-carrying water molecules than the bottom of it, creating a charge imbalance. Similar to what happens in a cloud, for example, in the context of lightning. This is how a generator was created that can run as long as there is moisture in the air. The energy produced in this way could be used to power a small device or be stored in batteries. However, we should not expect that in a moment we will sit comfortably in the park on a day when the air humidity is high and we will simply remove the panel, thanks to which, for example, we will charge the smartphone. Currently, the work is still at a very early stage. For example, a layer of cellulose material was able to generate a voltage of only 260 millivolts, while a mobile phone needs at least 5 volts. However, such layers can be accumulated, increasing their capabilities. The most important thing, however, is the fact that the observed effect exists and opens up many possibilities for us. Moisture is almost always present in the air, so such a generator could run 24 hours a day, 7 days a week. Rain or shine, night and day, regardless of whether the wind is blowing. This solves one of the main problems of wind or solar energy technologies that only work under certain conditions. Microfossils of primordial microbes found in rocks dating back 3.4 billion years. In South Africa, fossilized remains of microbes have been found that scientists indicate lived on the seabed near hydrothermal vents 3.42 billion years ago. These findings will help scientists better understand how life originated on Earth and where it can be found elsewhere in the solar system. Microfossils of ancient methanogens have been discovered by an international team of scientists led by researchers from the University of Bologna. This is the oldest evidence of this type of life on our planet and extends the boundaries of potentially habitable environments on the early Earth, as well as on other planets such as Mars. The research results were published in the journal Science Advances. Earth's subsurface habitats span a vast biosphere and likely represented one of the earliest sites of microbial life on our planet. While the origin of life is still debated, evidence of ancient creatures provides insights into its early evolution. We present the discovery of exceptionally well-preserved microfossils, approximately 3.42 billion years old, that inhabited the Barberton-Greenstone Belt hydrothermal vent system in South Africa. Combined with their morphological and chemical characteristics, they can be considered the oldest methanogens and/or methanotrophs that developed on the volcanic substrate, the authors of the publication wrote. The Barberton Green Belt is a region in South Africa, near the borders of Eswatini, formerly Swaziland, and Mozambique, containing some of the oldest and best preserved sedimentary rocks found on the planet. After analyzing the samples, scientists found a carbon-rich outer shell of the microfossils and a chemically and structurally distinct nucleus. We found exceptionally well-preserved microbial fossils that seem to thrive along the walls of cavities created by warm water from hydrothermal systems a few meters below the seafloor. Surface habitats, heated by volcanic activity, likely hosted some of the earliest microbial ecosystems on Earth, and this is the oldest example we've found so far. Barbara Cavalazzi, lead author of the study. These primal lifeforms colonized cracks and fissures in the seafloor, where the interaction of cooler seawater with warmer subsurface waters from deep within the Earth likely led to a chemically rich soup that was suitable for life. Chemical analysis has shown that ancient microorganisms contain most of the major elements needed for life. The high concentrations of nickel are similar to modern archaea, living in oxygen-free environments, using methane for metabolism. One of the great unresolved debates is whether life originated in a warm, shallow body of water, as Darwin proposed, perhaps with the help of meteorites or lightning strikes, or on the seafloor around hydrothermal vents. Over the years, scientists have presented studies that seem to confirm both concepts, but ultimately this issue has not been resolved. The new findings support the hydrothermal vent thesis and may help answer some questions about how and where life first appeared on our planet, or whether such microorganisms existed even earlier in Earth's history. One of the problems with studying the history of life around hydrothermal vents is that we don't have enough data. Every few 100 million years, the ocean floor undergoes a major transformation, and although we know that life is present there, its history is largely hidden. This makes the discovery made by scientists from the University of Bologna of great importance. Charging an electric vehicle in 10 minutes. Scientists have developed a new technology. Researchers have developed a lithium-ion battery that charges at elevated temperatures, greatly speeding up the process. Importantly, the battery does not degrade during such charging. New technology could soon allow an electric car battery to be fully charged in just 10 minutes. Lithium-ion batteries have had a huge impact on the modern world because of their ability to store a large amount of energy in a small, compact, reusable battery. For their contribution to the development of this technology, a trio of scientists, John B. Goodenough, M. Stanley Whittingham and Akira Yoshino, received the Nobel Prize in 2019. Lithium-ion batteries are great for consumer electronics, but in the automotive industry they currently raise more concerns than enthusiasm. One of the main barriers to the popularization of electric cars is the battery charging time, especially if we compare it to the time of filling the car tank with gasoline or diesel oil. The key to making electric cars more attractive both commercially and in use is to develop batteries that can be quickly recharged without significant loss of battery life. This seems to have been achieved by the team of Professor Chao-Yang Wang of the Electrochemical Engine Center at Pennsylvania State University. Researchers in the journal Joule described research into a battery with an accelerated charging rate. Perhaps soon, thanks to a new battery developed by Wang's team, owners of electric vehicles will be able to fully charge their cars in just 10 minutes. All thanks to a new design that heats the battery to increase charging speed. We have demonstrated that it is possible to charge an electric vehicle in 10 minutes, providing it with the energy to cover a distance of 200 to 300 miles, 300 to 450 kilometers, said Wang. We can do this by keeping the battery life at 2,500 charge cycles. This is the equivalent of about 500,000 miles of travel, about 800,000 kilometers, he added. Fast charging of lithium-ion batteries has been possible for some time. However, the problem is that when they are loaded quickly, they degrade just as quickly. All due to the deposition of metallic lithium on the anode. During fast charging, lithium ions moving from the positive to the negative electrode tend to form plate-like deposits on the surface of the negative electrode. This leads to a decrease in the capacity of the cell. But it can also cause voltage spikes and consequent battery failure. The batteries are charged and discharged at the same temperature. Scientists have discovered that the problem of lithium buildup can be solved by charging the battery at higher temperatures, reaching around 60 degrees Celsius. However, heating the battery has a negative effect on it, shortening its life. In a series of experiments, the researchers determined that their structure, heated for no longer than 10 minutes and then quickly cooled to ambient temperature, does not degrade. This solved the problem of lithium deposition and shortened battery life. During the tests, the researchers used commercially available industrial batteries. They equipped them with a structure made of nickel foil with a thickness counted in micrometers. This allowed the electrodes to be heated in less than 30 seconds, and this creates conditions for the rapid movement of ions to the negative electrode without lithium deposition on its surface. They then tested how the cells performed when charged at 40, 49 and 60 degrees Celsius. They compared this with a control battery charged at 20 degrees C. They found that at 20 degrees Celsius, the battery could sustain a fast charge for only 60 cycles before performance degraded significantly. The best results were achieved during fast charging at 60 degrees Celsius. The battery charged in this way can withstand 2,500 charging cycles without performance drops. That's about 14 years of normal vehicle use, or about 800,000 miles. Kilometers traveled. The researchers calculated, it is also important to cool the battery down quickly. Vehicle cooling systems can be used for this, Wang admitted. Already cooling down from 60 degrees Celsius to about 25 degrees C makes a huge difference for battery life. Until now, it was widely believed that lithium-ion batteries should not be operated at high temperatures due to accelerated side reactions. Our research suggests, however, that the benefits of avoiding the lithium coating of the electrodes when charging at elevated temperatures with limited exposure time far outweigh the negative impact of exacerbating side reactions. Wang explained. The researchers say the technology is completely scalable. Nickel foil increases the cost of each cell by only 0.47%. Scientists have detected traces of water in a distant galaxy. New observations made with the ALMA telescope in Chile have provided evidence of water in the most massive galaxy of the early universe. In the galaxy SPT031158, 12.88 billion light-years from Earth, researchers also discovered carbon monoxide. There are a lot of water and carbon monoxide molecules detected. This is the most detailed study of the gas content of a star-forming galaxy to date, and the farthest detection of water in space. The research paper was published in the Astrophysical Journal. SPT031158 is actually a two-galaxy system that was first observed by scientists at ALMA, Atacama Large Millimeter, Submillimeter Array, in 2017. Both formed when the universe was only 780 million years old. It was then that the first stars and galaxies were born. Scientists believe that the two galaxies may merge, and that rapid star formation not only consumes the existing gas within them, but could eventually turn them into massive elliptical galaxies like those seen in the nearer universe. Using data from ALMA, we detected both water and carbon monoxide molecules. Oxygen and carbon are first-generation elements, and in molecular forms of carbon monoxide and water. They are essential for life as we know it, explains lead author Srivani Jaragula, an astronomer at the University of Illinois. This is the most massive galaxy that we observe at high redshift. When the universe was still very young, it has more gas and dust compared to other galaxies of that period, which gives us many potential opportunities to observe particles and better understand how these elements influence the evolution of the cosmos, explains the scientist. Previous studies of galaxies have shown a connection between water and dust emission, which can be observed in the infrared. The dust absorbs ultraviolet radiation from stars in the galaxy and re-emits it as far-infrared photons, explains Jaragula. This excites water molecules, which scientists are able to observe. In this case, it helped us detect water in this massive galaxy. Studying the first galaxies to form in the universe is helping scientists better understand the birth, growth, and evolution of the cosmos and everything in it, including the solar system and Earth. Early galaxies form stars at a rate thousands of times faster than the Milky Way, says Jaragula. Studies on the content of gas and dust provide us with information about their properties, such as the number of stars being formed, the rate at which the gas is converted, how galaxies interact with each other, and much more, explains the scientist. According to Jarrigal, there is still much to discover about the galaxies of the early universe. Our study provides information on how far away water is in space. But it also raises an important question. How did so much gas and dust come together to form stars and galaxies so long ago? The answer requires further study of similar star-forming galaxies, the scientist says. These exciting results demonstrate the power of ALMA, said Joe Pess. Goldfish released from aquariums threaten ecosystems. Giant specimens were found in the USA. The city of Burnsville, Minnesota, has appealed to residents not to release unwanted pet fish into rivers and lakes. The appeal was launched after a huge goldfish was found in one of the lakes. Species bred in homes and released into the wild can cause great damage to local ecosystems and threaten native species. The city of Burnsville shared photos of several huge goldfish caught while exploring Keller Lake. Please do not release your pet goldfish into ponds and lakes. They grow larger than you think and contribute to poor water quality by destroying bottom sediments and plants, city officials wrote on social media. In Minnesota, goldfish are considered an invasive species that does not occur naturally in an area and can cause tremendous economic and environmental damage. This also means that releasing them into public waters is illegal. A goldfish kept in a home aquarium usually grows to about 5 centimeters in length. However, they grow much larger in the wild and can be difficult to remove. They multiply quickly and can dominate native species. These fish are a long-lived species and in captivity they have lived to be 20 years or more. Burnsville residents had previously alerted the city to the presence of goldfish in Keller Lake. So authorities decided to conduct a study to assess their population. We expected to find goldfish in the lake, but we were surprised by their size, said Daryl Jacobson, Burnsville's natural resources manager. According to Jacobson, goldfish tend to adapt to their environment and therefore can be small in the home aquarium. But when released into the wild they grow to quite large sizes. They're a tough species. They can survive under ice or in water with low oxygen content, he added. Wildlife researchers are dealing with a similar problem in nearby Carver County, where 50,000 litter was removed from watercourses last October. Goldfish. This was part of a 3-year plan to study species that cause damage to ecosystems across the United States. But the US isn't the only country with a problem with wild goldfish. In 2017, the City Council of Munich, Germany, reported shoals of goldfish that deprived all rivals of food in local ponds and lakes. The problem has become so serious that the city has threatened to fine anyone caught releasing pets into public waters. Giant goldfish have also been found in UK waters. In 2010, a British teenager pulled a fish weighing 2.2 kilograms and measuring nearly 40 centimeters in length from a lake in Dorset. Canada and Australia also had problems with goldfish.